Hello and good evening. My name is Azlan Biwaka, magic number 208471. Today I will teach how to answer the question 18 for the question 18 in assignment 1. So question 18, it show in a 45-degree band of rectangular A, thus of 1 meter cross-sectional area is gradually reduced to 0.5 meter square area. So we need to find the magnitude and direction of the force required to hold the dust in the position if the velocity of the flow at the 1 meter square section is 10 meter per second and the pressure given is 2.943 Newton per centimeter square, and it also give a density of 1 kilogram over meter cube. So this question, it show the diagram. So we need to find the force. Basically we need to find the force to hold the dust position in this tube. So to solve this question, first of all we need to read the instruction and we look for the diagram, and then we make what is given on the question. So the given is the band of rectangular egg dust, which is the angle which is 45 degree, and it also give two different area, which is 1 meter square and 0.5 meter square. It also give a velocity which is 10 meter per second. It also give a pressure which is 2.943 Newton per centimeter, and it also give a density of air which is 1.16 kilogram per meter cube. And so we know the gravity is 9.81 meter per second. So the question, after we make given and we also make what is required for the question, so the required is to find the magnitude and direction of the force to hold down the dust position. So basically this question asks for what is the force inside this bending tube. So to solve this question, which is solution, basically we need to make the Bernoulli equation. So Bernoulli equation, they have two type, I think. First is the Bernoulli equation that use specific weight, and second is that use density and gravity, but it's depend on the question. The one that I use is the density, because the question give the density of the air, which is 1.16 kilogram per meter cube. So after we type the Bernoulli equation, so we see what is we can cross-sectional or we can discard. So from this question, Z, or we call it elevation, so we can discard the elevation because the elevation on the point 1 and point 2 are the same, because the question did not say anything about the elevation. So we can cut it from the equation. But if the question asks anything about the elevation, we must not cut it, but we must take the number. So we after we discard the elevation, so what we will get is we will get the Bernoulli. So from the Bernoulli equation we will get this kind of formula, and then from this formula we will put what is the given number into this formula. So from this Bernoulli equation we will get the pressure at the point 2, which is the thing that we want to find from the Bernoulli equation. So we just plug in the number, which is the density is 1.16 kilogram per meter cube times by the gravity, which is 9.81 meter per second, and we need to time the pressure at the point 1, which is 2.943. So from this pressure we see that the question given is Newton per centimeter cube, but we must change it into Newton per meter cube. So we will get 2.943 times by 10 power of 4. So same goes with density, we get 1.16 times by 9.81. So the velocity at the point 1 is basically is 10 meter per second, and velocity at the point 2 basically we can calculate it using the formula Q equal to AV. So from the formula, which is the flow rate, so in this tube the flow rate is equal from point 1 and point 2. So from the formula Q equal to AV, we can get the velocity for the point 2, which is 20 meter per second. Then we plug in the equation, and then we get the pressure, which is 29256 Newton per meter cube. And then after we find the unknown number from the pressure, we need, because there is a slope in this tube, so we must take the force bending on the x and y direction. For the x direction, so for the x direction we use this formula, which is the density of A time by the flow rate equal to multiple by velocity 1 minus v2 cos theta plus p1 a1 minus p2 a2 cos theta. So this formula we can get it on the slide basically. So for the force acting on the x direction, we just plug in what is the number given, which is just put in the given number based on the question, and then we will get the force on the x direction is 9036.98 Newton. Same goes with the y direction. The formula is density of air times flow rate multiplied by negative V2 sin theta minus P2 A2 sin theta. So from the question, we just need to plug in the number. So after plug-in, so the question show the negative sign. So basically negative so the negative sign, basically the negatives indicate the direction of the force. So if it's positive, if acting on upward, but if it show negative, it show the downward. So just for the reference for us. Then after we take the x and y force, so we can get the resultant force. So this resultant force. So basically we need to find the resultant force and the direction. Based on the question, we need to find it. So to find the resultant force, we use the formula given. Just plug in the fx and fy number, and then we will get the resultant force, which is the force that required to hold the dust in the position of this tube. So this is our answer. And then to find the magnitude, this is the answer. So to find the magnitude, basically we can draw the force diagram with the so we need to draw the force diagram. So basically to find the magnitude is we need to find the area between the area between resultant force and fx. So to find the angle, basically we need to use formula Tuasoka, which is Tuasoka. So to find the area, we use tan theta equal to fx over fy. So fx is based on the answer force acting on x direction, and fy is based on our answer on force acting on y direction. So then from the equation, we will get the angle, which is 28.9 degree, which is the magnitude for the force. So that's all for me. Thank you.